This is the solution to the 2006 physics high-level paper question 6. So the first thing is to define velocity. So we know that velocity is speed in a given direction, okay? And speed is rate of change of position. So how do we get all that together? So and the easiest way to say it is that velocity is the rate of change of displacement, okay? Because displacement is has tied into it rate of change of displacement. Right, so displacement is like your direction and your distance from your original position, which is an easy way of talking about velocity, or the change over time. Okay, part 2 was define angular velocity. Okay, so angular velocity is the rate of change of angle. Okay, so it's the change in angle over time, the change in angle, rate of change of angle. Yeah, that's fine. Change of angle per second is what we're trying to get. Derive the relationship between the velocity of a particle traveling in a uniform circular motion and its angular velocity. Okay, so this next bit here is we start off by defining what the radian is. So angle in radian is S over R, where we have an object that is moving a distance S through a radius R and makes an angle theta here. Okay, so theta is S over R. And then we're going to divide both sides by T. So we have S over T is equal, theta over T is equal to S over RT. But we know that theta over T is angular velocity, omega, and S over T is velocity, V. So then we can say that omega is V over R. Is that the way we want it in the end? Derive the relationship between the particle, the velocity, and its angular. Yeah, well, okay. So another way to put that, and the normal way we put it, is that the V is omega R. Okay. What kind of time am I at the moment? Oops. Good, I've got more time. All right. A student swings a ball in a circle of radius 70 centimeters in the vertical plane as shown. The angular velocity of the ball is 10 radians per second. What is the velocity of the ball, and how long does it take the ball to complete one revolution? Okay, so let's write down what we know. We know that the radius is 0.7 meters, 70 centimeters, and we know the angular velocity is 10 radians per second. What is the velocity of the ball? Well, we just did that. It's 10. Let's always write down the formula. V is omega R, which is equal to 10 by 0.7. So we get 7 meters per second. And then how long does it take the ball to complete one revolution? The time to complete one revolution. So the period of an object is 2 pi divided by its angular velocity. Okay, so this is, remember, one in radians, this is one full circle, and this is radians per second. So if we yeah, that's it, 2 pi over omega. So it's 2 pi over 10, which is going to be 1/5 of pi, 2 times pi divided by 10. So the length of time is 0.628 seconds. Okay, all right, let's leave it at that.